Okay, late last week we had assigned this assignment, implicit differentiation notes, and I want to do a couple of these problems today. And I want to look at problem number 2 first. And here we have 2y equals x squared plus sine of y. And what you have here is implicit differentiation means just take the derivative with respect to x of everything in place. So what we have here, this first term on the left, 2y, we take the derivative of 2y with respect to x. That's going to be 2y, 2, right? The derivative of a variable to the first power will be just the number, because we have y to the 1 power becomes 2y to the 0 power, which is just 2, times the derivative with respect to x, dy dx, equals the derivative of x squared is going to be 2x times the derivative of x with respect to x. Okay, and the last thing we have to differentiate is this sine y, which is going to be, let's see, cosine y times the derivative of the inside, which is going to be dy dx. And I hope you notice that dx over dx here, next to this 2x, they're going to cancel to equal 1. And so the next thing we do is to gather all terms of dy dx to one side of the equation. And to do that, we're going to subtract cosine y dy dx from both sides of the equation, minus cosine y dy dx. And we have a cancellation to 0 on the right side, and remaining we have 2 dy dx minus cosine. And one thing I didn't do is initially we have that y in parentheses. I'm going to go ahead and reinsert where I omitted. There's the y in parentheses, y in parentheses, y in parentheses. Okay. Cosine y in parentheses dy dx. And that is going to be equal to, what we have remaining on the right side is 2x. And now we factor out, and we've engineered this so we have a common factor of dy dx in each of these terms. So we take dy dx, which is our common factor, which we've engineered to be our common factor, so as to be able to solve this. 2 minus cosine y equals 2x. And now what do we do if we divide both sides of this equation by the expression 2 minus cosine y? We have on the right side 2 minus cosine y. All right. And we have a cancellation. Cancellation by division is to equal 1. So as a final answer, we have dy dx is equal to the expression 2x over 2 minus cosine y. So that's our answer. We box in as correct. There we have it. Okay, now let's go on to this one here. As 3 is not with the trigonometric ratio, we're going to use a product rule here. 4, I told you to omit 4 until we get to the We'll maybe come back to 4 when we go into logarithmic differentiation soon. Problem 5, find the instantaneous rate of change for x squared plus 2xy plus y squared equals 4 at 1 comma 1. So this is the one we're going to do. And we're just going to differentiate this expression to the left in place. And the derivative of x squared is going to be 2x. And it's dx over dx, right? Because we've differentiated with respect to x, which is going to be 1. So we just kind of leave this alone. Next, we're going to take the derivative of 2xy implicitly. And what we're going to do is take if you look at kind of the uv, right? So plus 2, and we're going to have x times the derivative of y, which is going to be dy dx, plus 2y times the derivative of x, which is dx over dx, but we'll just assume that we know that we cancel that, and we'll just leave that alone, plus we have the derivative of y squared, which is 2y dy dx. And lastly, we have the equals 4, and the derivative of 4, the derivative of a constant, is 0. So there we have that. Next, we're going to cast off, we have these 4 expressions on the left side of the equation. We're going to cast off anything that does not have this factor dy dx. And to do that, we're going to subtract from both sides 2x and 2y. And we do the same thing, use the golden rule of algebra on the other side of the equation. And we have left, we have 2x dy dx. And we've canceled these things here. Plus 2y dy dx. And that's going to be equal to negative 2x minus 2y. And now factoring out our common factor, and we actually have common factor, we do have 2, right? That's going to help us simplify later perhaps, but let's just factor out the dy dx. So we have the common factor dy dx is equal to times what? We factor out the dy dx, so we have left here, we have 2x plus 2y equals negative 2x minus 2y. And now we divide both sides of this equation by what we have factored out. We have 2x plus 2y. That's on the left side. On the right side, we divide by the same thing. 2x plus 2y. And we have a cancellation. And remaining, we have, I'm going to write this to the left. We're going to have to do some more simplification to the right. I think this is going to simplify out pretty nicely. Dy dx is equal to negative 2x minus 2y over 2x plus 2y. And what we can do is, working to the right now, dy dx is equal to, we can factor out a negative 2 from everything in the numerator. So we have negative 2 times x plus y over, we factor out a 2 from the denominator, we have 2 times quantity x plus y. What do you know here? We have a cancellation, So we have, we have negative 2 over negative 2, negative 2 over 2, excuse me, equals negative 2 over 2, which equals negative 1. Therefore, dy dx simplifies to negative 1. And that will be our implicit differentiation for problem number 5. Simplified out quite nicely here. And it really doesn't matter at 1 comma 1, right? We plug in 1, well, we just have negative 1 no matter where we plug this in. So our instantaneous rate of change, no matter where we are, is going to be negative 1. So we don't even have to plug this one. There's nowhere to plug in on the right side, is there? And we can see if we go ahead and plug in earlier, we could have plugged in instantaneously right here. Negative 1 and 1. If we did that, we'd have 1 plus 2. That would be 2 plus 2. And then we'd have, no, on the right side, excuse me, we simplified this. We'd have negative 2 minus 2. Yeah, we have 2 minus, that would be negative 4 over positive 4, okay, which we'd have negative 1 no matter which way we look at it. Okay, so that's going to be our homework help on this exercise. Good luck, stay warm, and thanks for viewing.